FastMCP 2 employs dependency injection to resolve runtime values, enabling tools to access authentication tokens without exposing them in the MCP schema. This mechanism ensures clean function signatures while providing secure access to request-scoped context. The upcoming code demonstrates how to initialize a FastMCP server and define a tool that retrieves a user ID from an injected access token. The setup involves importing necessary dependencies and decorating a function to automatically handle token extraction. From FastMCP, import FastMCP. From FastMCP dependencies, import current access token. From FastMCP server auth, import access token. MCP equals FastMCP demo. At MCP, tool. Async def get user I token. Access token equals current access token SDR. Return token claims get sub, unknown. This code demonstrates FastMCP's dependency injection system for accessing authentication tokens in tools. The getUserid tool uses current access token as a default parameter value, which injects the authenticated user's token at runtime. This pattern keeps the tool's signature clean while providing secure access to user identity through the token's claims. The access token object contains standardized claims like sub-subject user ID and provider-specific data. By using dependency injection rather than manual token passing, FastMCP ensures consistent authentication handling across all tools while automatically excluding security-sensitive parameters from the MCP schema. This approach simplifies tool development while maintaining security boundaries. The explicit current access token syntax makes the dependency visible in the signature, which can be preferable for security-critical parameters. Alternatively, you could use type annotation with access token for more concise code. Both approaches provide the same runtime behavior, with FastMCP handling the injection automatically when the tool executes. Let's break it down. From FastMCP, import FastMCP. Imports the FastMCP class from the FastMCP module, which serves as the main entry point for creating MCP Model Context Protocol server instances. The imported class will be used to instantiate a server with a specified identifier label. From FastMCP dependencies, import current access token. Imports the current access token class from the FastMCP dependencies module, which provides access to the authentication token in the current request context. From FastMCP server auth, import access token. Imports the access token class from the FastMCP server authentication module, providing access to token-based authentication functionality for validating and managing access tokens in the MCP protocol context. MCP equals FastMCP demo. Creates an instance of FastMCP with the server identifier demo. The string parameter serves as a label for identification in MCP protocol handshakes, allowing clients to recognize this server instance. This line initializes the FastMCP object, but doesn't configure any functional behavior or operational mode. At MCP, tool. Decorates the following function as a FastMCP tool, enabling automatic registration with the framework. The decorator signals that the function should be exposed as a callable tool in the model context protocol, using the function's name, docstring, and type annotations to generate the tool's interface schema. Async def get user I token. Access token equals current access token SDR. Defines an asynchronous function named getUserid that accepts an optional token parameter of type access token. If no token is provided, it defaults to the result of calling current access token. The function is declared to return a string value representing a user ID.
Return token claims get sub unknown.
Retrieves the subclaim from the token's claims dictionary, returning unknown if the claim doesn't exist. This extracts the subject identifier from a JWT token, commonly used for user identification in authentication contexts. FastMCP2's dependency injection system elegantly handles authentication by injecting the current access token at runtime, keeping tool signatures clean while ensuring secure access to request-scoped context. The getUserid tool demonstrates this pattern by using current access token as a default parameter, which automatically resolves to the authenticated user's token when the tool executes. This approach maintains security by excluding sensitive parameters from the MCP schema while providing explicit visibility of dependencies in the function signature. The access token object then serves as the bridge to standardized claims like sub, enabling consistent user identification across tools. By combining these elements, dependency injection, clean function signatures, and secure token handling, FastMCP simplifies tool development without compromising security or clarity. The trade-off between explicit dependency declaration and concise type annotations offers flexibility, but both approaches leverage the same underlying injection mechanism for consistent behavior.
The token claims its identity, yet the server greets it as a stranger.